In chapter 2, we looked at graphing inequalities. Today, we're going to look at solving systems of inequalities. So you're going to see more than one. The first problem on your note sheet says during one heartbeat, blood pressure reaches a maximum pressure and a minimum pressure, which are measured in millimeters of mercury. It is expressed as the maximum over the minimum. For example, one blood pressure you might have would be 120 over 80. Normal blood pressure for people under 40 years old ranges from 100 to 140, and the maximum would be from 60 to 90 for the minimum. Express this as a set of inequalities. All right, so if we're going to express this as inequalities, we have to use variables for one of them. So let's say we use x as our maximum, and let's use y for the blood pressure minimum. So we want to write this out now as a system. So the first thing it says about our maximum is that it should be from 100 to 140. What that means is x compared to 100 should be greater than, or it could be equal to, because 100 would be included, greater than or equal to 100. Similarly, we want it to stay less than or equal to 140. With y's, our minimums, we also have an upper and lower range. So compared to 60, we want it to say greater than or equal to that and less than or equal to 90. So that would be our set of inequalities for this one. If you graphed that out then, as you can see in your graph on your note sheet, the maximum pressure then would be given by these lines. These would be horizontal and vertical lines. Any of these graphed with x, so these two, when graphed, would be vertical lines, because they're x equals ones, and these would be horizontal lines, because these would be the y-intercepts and the slope is 0. So you can see it's graphed over here. Here's the minimum of 60 pertaining to that one. Here's 90 right in here pertaining to that one. And then these vertical lines would be the 100 and 140 we have right over here. So once you have them all graphed, then what we're going to be doing is shading, because remember with these ones you have to shade. So the shading for the vertical lines would happen in between. The shading for the maximum would be shaded in between as well, because they have to be between there. The overlap in shading happens in this yellow area right in here. So this area is the area that shows all the normal blood pressures that a person under 40 could have. So what you look for when you're doing these is the overlap in shading. The overlap in shading is where all your solutions lie. All right, one of the things you're going to need to be able to do in these is come up with inequalities. So that's what this first example is looking at. We want to come up with inequalities that represent this. So it says Classy Catering needs at least 15 food servers and 5 bussers to cater a large party. In order to make a profit, they can have no more than 34 food servers and 7 bussers working at an event. Write an inequality for this. All right, well, one thing you got to come up with is variables. The two things they're talking about here are food servers, so let's use F for food servers. And let's use B for the bussers. All right, so what we need to do now is write inequalities. They say they need at least 15 food servers. So that's F for food servers. And remember, at least, we've talked about this before. That means that's the minimum, or you could have more. So that would be greater than or equal to. At least means greater than or equal to. So we need at least 15. It can be more than 15, but the minimum number can be 15. And they also need at least 5 bussers. Well, 5 bussers, at least 5 would again be greater than or equal to 5, but this would be B. All right, so reading on. In order to make a profit, they can have no more than 34. No more than we've talked about that is for, that would be less than or equal to. So the food servers, there has to be less than or equal to 34. And for bussers, in order to make a profit, we have to have no more or less than or equal to 7. There would be our system of inequality. So now if we wanted to figure out what they could have, we could graph that out as some vertical and horizontal lines, and we could see where the shading happens. All right, let's actually do some graphs now. So number 2, they want us to graph out and find out where's the solution set for this one. Notice these two lines are inequality, so we're going to have to do some shading, but also notice they're in slope-intercept form. They don't have an equals, but they're in the form where we have a slope and a y-intercept. So we should be able to graph these out, hopefully not too hard. Let's go with our first line here. We want to graph out the line y is greater than or equal to negative 2x plus 4. The y-intercept would be 4. The slope would be negative 2. And remember, slope you always can put over 1, so it'd be negative 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. We want to connect this with a solid line. Anytime it has the or equals to, you want to connect it with a solid line. All right. Now we want to figure out where we're going to shade for that one. Now when you're figuring out where to shade, pick a point again that you can use as a test point and see if it makes sense. We did not pass through 0, 0, so let's test that point out. If we put 0 in there, we get 0 is greater than or equal to negative 2 times 0, which is 0, plus 4, so we'd have 0 is greater than or equal to 4. That is false. So 0, 0 did not work, which means we want to shade on the opposite side of that line. So our shading needs to occur opposite where 0, 0 is. So everything in this region. All right, now last chapter at this point we'd be done. However, we have another line here that we also need to graph. So we also need to graph this one out. So let's graph that one next. That one has a y-intercept of negative 2. Its slope is, there's nothing in front of the x, so there'd be like a 1 there. So the slope would be 1 over 1. So we want to go up 1, right 1, up 1, right 1, and continue that. Or we could go opposite way. This one, too, would be a solid line because it has the or equals to. But now we also have to figure out where the shading is going to occur for this one. So again, pick a test point. 0, 0 should work again. If we put 0 in here, we get 0 is less than or equal to negative 2. 0 is not less than negative 2. 0 is bigger than every negative. So this again came out false. So we want to look at where 0, 0 is the origin and shade on the opposite side of that line. So we want to shade, again, opposite. So if we shade opposite of that one, across from 0, 0, this side would be the one we'd want to shade on. So now you want to look, where did that overlap in shading happen? It was this section right here is where the overlap happened. So both of them got shaded in this section. That's the part you want to then take your pen and darkly shade in, because this is the area where all our solutions happen. It only got shaded right here for this one and only right here for this one. This was the part where the overlap occurred. All right. Let's look at the next one. On number 3, they want us to graph and shade this one again. We again have another slope-intercept line. We're going to graph the second one first. We just did one of those, so start at negative 1. Slope is the same as that other one, up 1 over 1. So we should graph that out. Connect it with the solid line again because it is or equals to. Do a test point. Let's do 0. 0 is greater than or equal to negative 1. That one came out true. So now we want to shade on the side of 0, 0. So let's take and shade here. So now we're shading on the side of 0, 0, everything over here. This next one, though, is a little bit different. This is an absolute value one. You can see we got absolute value. Remember when we were doing absolute value with these, if you have absolute value less than 3, what that really means is that y is going to be less than 3. It also means, though, it could be greater than the opposite of that, which is negative 3. If you write these out as two separate ones, that's saying y has to be less than 3, and also that y is, if you just write this part the other way, that y is greater than negative 3. So there's actually two inequalities we need to graph for that one. This one and this one. Both of these are slope-intercept lines, but both of them have like a slope of 0. This is really saying y is less than 3, but we have a slope of 0. This one's saying y is greater than negative 3, slope is 0. So to graph them out, those are going to be horizontal lines. So there's one horizontal line at 3 with a y-intercept of 3, and these ones would be dashed or dotted lines because it doesn't have the or equals to. The other one would go through at negative 3. And again, be horizontal, the slope is 0. For this one over here, it's saying x is less than 3. Well, every point less than 3, that's going to be below it. So when we shade for that one, that would be everything underneath it. So everything here. Okay. And the other one is saying everything greater than and greater than that. So the other one you'd want to shade above the negative 3 line. So everything here. Well, where did the overlap happen for all of them? That would be right in this section in black here. This overlapped section right here, that is the solution set for this one. Everything in that area is the solution. So the overlap is always the solution. All right. On the back, what I want you to try for tomorrow is try graphing out number 4. So I want you to see if you can graph out and shade this one in. So for number 4, those are in slope intercept. I think you can get that one. Graph them out, shade in, see where the overlap happens. Also for tomorrow on number 5, I want you to see, we want to be able to graph this one too. Notice they're not in slope-intercept form. So see if you can change both those equations to slope-intercept form tomorrow, and we'll graph those ones out as well and finish up your note sheet.